Okay, let's dive into Unit 2 here. So first, a little overview of Unit 2, which is typical in these units. We'll have some new material, which we'll cover in just a sec here, and then we'll go into a learning practice activity. There'll be a separate video walking you through this Colab notebook in that example. And then there's the discussions. Remember, you have to post 2 topics throughout units 1 and 2. And then now, since we're on the second unit, project 1 will be due. So by this Sunday, project 1 is due, the 2 discussion topics are due, and then the learning practice activity is due. So those are the 3 things that will be due in this unit. So let's jump into some of the new material. We're going to be looking at cleaning data and data visualization. So I'm going to go to this link here and start off talking about some of this material. So let's start talking about cleaning data. So I have pointers to 3 different articles here, which I think provide a pretty good introduction to this material. The first one is from this elitedatascience.com article. It has some good visuals. It actually views real well on a cell phone or something like that. It just talks about cleaning data, what cleaning data is, talks a little bit about visualization and the framework. Talks about why we want to clean data. You know, we really need clean data to get good results of our algorithms, the old garbage in, garbage out saying it certainly applies to our data here. So then it talks about removing unwanted observations. And again, this is just not data that doesn't fit your view of what it should, but actually erroneous data, data that is duplicated or irrelevant or has typing errors in it or something like that. So it talks about duplicate observations. Sometimes, especially when we're bringing in data from multiple data sources, we might have the same thing listed a couple times, so we want to find and search for those. Sometimes we'll have stuff that's just not relevant, like you might have a larger data set and it might, like we just looked at a Kaggle survey and had from respondents from all over the world. I really wanted just to limit it to the United States, so I limited it. I removed observations that were from countries outside the United States because that's what I really wanted to focus on. So you can watch that. Then it talks about structural errors. So this is like typings, inconsistent capitalizations, stuff like that. So if you look at this graph, it looks kind of good, but then you start noticing things like asphalt is spelled or capitalized 2 different ways here, and so it's listed as 2 different things. Same with shake dash shingles and shake shingles are listed twice. Composition, so there's a lot of spelling errors here, or just not the same categorization. Obviously, they didn't maybe have data that came from a pull-down list here. Maybe people were typing in things or doing things like that. So often we want to try to combine these into set groups here and combine them and replace inconsistent capitalizations and stuff like that. Also, we want to watch for mislabeled things that have NA or not numbers or empty fields here. Then we do want to look at some outliers. Now we need a reason for removing outliers. You just can't remove them because they are you think they're bad. You need to have some justification. So in general with outliers, we talk about the innocent until proven guilty here. You've got to show them. And a typical example might be you notice that someone was entering a dollar amount and most of the dollar amounts are like 255 or something like that, and you notice one that is $275 for a candy bar or something like that, and you realize that that person just missed a decimal point. Or again, we might see negative values where someone entered a negative value and it should have been a positive value, so it might be minus 275 for a candy bar. So again, when we're looking for outliers, that's typically we want to look for outliers that are obviously wrong or incorrect there. So the another question we have to look at sometimes is missing data, and how do we drop data that is missing, or do we work with it in different ways? And this is a whole field. We're not going to go into this, but we'll tend to use data that is pretty full and then tend to drop missing values in our work just to keep things simple because we're more focused on the machine learning aspect of this, not the data cleaning aspect of this. here, but it's talking about that. So that's this article, nice layout. This article has a little more complicated framework. I'm not going to go into too much into this, but thought some of you who are going to go into data science might want to read this sort of article. It talks about kind of our layout. What is data in? The garbage in, garbage out stuff. And then kind of our index here. What is data quality? What is validity? How do you know your data is valid? What is accuracy? What is completeness? What is consistency here? And uniformity. So those kind of ideas of data here. Um, so like valid data usually has to fit some constraints. Often are we have some rules, some business rules that set constraints like the type of the data, that this has to be numeric value or it has to be in a certain range, things like that. Accuracy, you want to make sure we're accurately measuring data and bring it in for this, and if it's data that's in up to interpretation, how are we measuring that? And also completeness, that we're getting all the data from all the different sources correctly, and tied to that with consistency. Consistency is very important, especially when you're pulling data from multiple data sources, multiple tables or stuff like that. So are the units the same from these different sources? So if you have different hospitals you're collecting data from, are they measuring things in the same way using the same format for that? So this also kind of goes through a workflow, typical workflow, and again, that's nice layout. And it goes over then some examples of cleaning data, again, similar to what we've seen before with the other example. So the last one I want to just mention is this what is data cleaning example. This is a nice article in that it talks a lot about Python and does a lot of stuff we'll be doing in our activity just after this. So it talks about data cleaning and ways of that, and but it also then uses data in NumPy or in Panda array. So it sets up a Panda array here, and then talks about how do we drop a column here, and then shows you the general syntax for it, and then the actual command for dropping a column. In this example, the data is stored in a data frame in a variable called df. So you'll see this df a lot, and that will be the data frame that they're using. They create that data frame up here. And df is just a common variable name for a data frame here. So here's this data frame dot drop, and then the column height, and they're saving that into the same data frame here. So again, they talk about missing data, these numbers, how to do that. And again, we'll be going over some of that. But this is a nice descriptions of this stuff. So if you're looking for a little longer descriptions, this is a good place to start. So then let's talk about visualization of data. So we'll be using 3 different libraries as part of Python for this stuff. Okay, the first is that pandas with their data frame has a plot command. So you can do some simple plotting with that, and you often will see people do that. And so this is just kind of an overview of the plot command. I don't think this would make much sense to you initially, but there are some instructions, and we'll look at some examples of the plot command. There are also different types of plots. So plot dot, our data frame plot dot bar, plot dot box, plot dot histogram, or line, or scatter. So we can run different plots here for our data. And we'll see those examples in just a second when we get down to this collab here. Another commonly used library for plotting or graphing is matplotlib. The matplot library is a well-known library that has lots of tools for plotting things and creating multiple plots and grids of plots and things like that. This is a very complicated library, but it does all the basic things: bar graphs, scatter plots, pie plots, box violin plots. And again, we'll just look at some examples of that throughout this course. So sometimes you'll see that. Now, when we import that, we generally import it with the name PLT, and so in our code you often see plt dot, and it'll be imported. In fact, if we look, well, we'll look at our code. And often, like when we see our code, we'll import the library. We'll import the matplotlib, the plot library as PLT. And then anytime we say PLT dot something, it'll be using this library. The next library is the Seaborn, and again, we generally import it as SNS. So that's our last example, is the Seaborn library. And this is a more complicated library that does some really cool, visually appealing graphs. Here it actually uses Matplot underneath it, but is built on top of that, and it has some really nice, fancy examples of types of graphs you can create relatively easy with this. And again, this isn't a data visualization course, so we won't be doing too much in it, but we'll just be playing with this a little bit here. So then the last thing we're going to do here is look at this notebook. So this is a Unit 2 notebook. We'll just go through some examples of that, and I'll post a separate video in this walking you through that.